Hello and welcome back to Calculus 2 Saturday edition. We are going to talk about comparison test, and we have two of those. One is called direct comparison, which is used less, and the other one is called limit comparison, which is used more. Now, who needs the paper with all the tests? Anyone else?
Thank you.
You guys have one?
I'll send the picture and that's up to him.
Perfect, thank you. You guys are the bomb.com.
So we are going to look at this. So the sheet that I gave you, right, has all 10 tests that we are learning. So the way you had different derivative rules, the way you had different integral rules, these are the 10 series rules which are telling you the convergence or divergence of series. And now we're going to look at the last two on the sheet. Comparison tests, I also like to call them the last resort tests, because generally if everything else fails, right, this is the only thing you can do, and then it's game over. If that doesn't work, then you have to start coding. So these two tests will both work in the beginning in a similar way. You are going to extract the sequence AN from your series, and then you are going to construct a similar BN whose sum either converges or diverges, and then whether, depending on the method, you will claim convergence or divergence of the original series. So the first series we are considering here is direct comparison. And for these, you will have to do the proof to show which sequence is larger, and then you will claim convergence or divergence on the series. So first, we're going to write our red theorem, definition, whatever. So for AN and BN being positive, right, we're going to have, let, and then we'll have for let. Not trigger any computer science majors here. So let AN and BN be sequences with positive terms, right? And now we're going to have if AN is smaller and equal than BN, and summation of BN converges, then summation, these are infinite, of AN converges as well. So that's like number one. And number two, if AN is larger than BN and summation of BN diverges, then summation of AN diverges as well. Ta-da! That's it. That's the life. So we'll put this on a cloud. This is your row number 9 on the paper I gave you, the chart I gave you. And with this, right, we are going to deal with problems that are close, right, but not exactly either geometric or something. So what would be an example of the direct comparison? So say you have 3 over n plus 4. I might have to change it. Let me see. My brain is not working. Let's start it. We can start anywhere. We can start at 1, whatever. your an is 3 over n plus 4. That's where your an is. And you look at this and you say, this would be amazing P series, harmonic series, whatever you want to call it, if this stupid plus 4 wasn't there, right? Because you would be able to claim divergence instantaneously. Because last class we learned that harmonic series 1 over n, sum of 1 over n, diverges. Well, whether it's 1 over n or 3 over n or 100 over n, it's still going to diverge. But we have this plus 4, which means that it's not that anymore. And now we would like to compare it to the Bn, which is, let's say, 3 over n, whose summation would diverge by P series. So now, since I am looking for divergence, because this is close to 3 over n, and we know that 3 over n in the sum will diverge, because they're close, we need to prove that an is bigger than bn. See, that's how I know we needed a minus here now, right? In order for this to work. This one is very sensitive. That's why limit is better. So change that plus into minus and it should work. So now, need to show that an is always bigger than bn. We already have that divergence there. So if we are able to establish this, we're done. So we need to show that 3 over n minus 4 is bigger or equal than 3 over n. When you cross multiply, you get 3n bigger or equal than 3n minus 12. And since n is not 0, right, n starts in this case at 1, so you can subtract 3n on both sides. Well, you can divide, it doesn't matter. Actually, you subtract 3n on both sides, and you get 0 is bigger than negative 12. That's true. So now we say, since an is larger than bn, and summation bn diverges the series, summation of 3 over n minus 4 diverges by direct comparison test. And that's the answer, right? So whatever I write here in red, right, in this box, is what gives you credit. The rest is partial credit prior to this sentence. This sentence states, you know the theorem, it states the answer, which is series is divergent. Let's say you have summation of 4, let's do it this way, hold on, wrong, 4 over 3 to the n plus 2 from 0 to infinity. What kind of problem is this if I don't have the plus 2? The what?
No, it's a geometric.
Geometric series, yes. So it will be, right, this would be equivalent here. If there was no, let's use something interesting. How about the wood? So this can be rewritten as 4 times 1 over 3 to the n. There. So it's definitely geometric. But we have the plus 2, so it's not geometric. All right, so what's the an?
And it's going to be 4 over 3n, 3 to the n plus 2.
Plus 2. And the bn we are comparing it to?
Could be 4 over 3n.
So it's exactly what we had, right? So now we know that the summation of Bn converges by geometric series, which is the line number 3. No, number 2. Line number 2 on the sheet I gave you is geometric, right? So we are trying to establish convergence, and if you're trying to establish convergence, you need to show that AN is smaller than the BN. And I'll explain, now that we did 2 examples, I'll explain this more. So need to show that AN is smaller than BN. Okay? So what do I have? 4 over 3 to the n plus 2 needs to be smaller or equal than 4 over 3 to the... I need a minus here. Changing the problem into a minus. So it works. Again, these problems are solved by limit, guys. So the limit one is much better than this. So now when you multiply both sides by 3 to the n, you get 4 minus 2 times 3 to the n, less equal than 4. We quickly see that this holds for n larger than 0, because you have you always have negative number. I mean, you can subtract 4 on both sides and so on, but 3 to the n over here would make this negative, so this is negative, and that's definitely less than a positive 4. So it holds, and then we just, as the answer, we say, since AN is smaller or equal than BN, and summation BN converges, the series summation of 4 over 3 to the n minus 2 converges by direct comparison test. And that's what you box. That is your answer. So what do I achieve? How does it work? It seems like we're stacking the deck, right? You are picking something that you know is going to converge, and then you match your problem to converge, right? Well, it's not exactly that. Remember that we had 2 cases up there, and I'm going to draw now graphs for those cases, and you will see that, right, the common sense should help us determine. So this is n, right, for these graphs, and for number 1 we have that you want to show convergence, right? You want to show convergence. So you have some crazy AN that you can't deal with easily. The black dots are AN. And then you have something nice as a BN whose summation converges. So you see that the condition that needs to be satisfied is that AN is in between BN and a 0. So both are positive, right? We started our theorem, both are positive. And what's happening here is that AN, the erratic one, is getting squeezed in between BN and 0. So technically it's forced into convergence, right? So that's the reason why, in this case, AN needs to be smaller or equal than BN. So that's why you are proving that statement. You make your claim, right? And then you just need to prove the statement. So if the statement is true and BN, sum of BN converges, then sum of an has to converge because it's trapped in between. Now on the other side, you have again this an that it's all over the place, and now you are coming up with some bn, but that bn in a summation is going to diverge. So now you see that you're I'm supposed to draw this one underneath, sorry. You draw this one underneath, so it so let me put the an here. You draw this one underneath because you want this one to be divergent. There we go. And then the bn smaller than an or an bigger than bn is pushing bn is pushing an into divergence, right? Because the one that is underneath, that sum diverges, so the one that sits on top also has to diverge. So these graphs are ones that help understand those two lines from the theorem, and you understand why you have to, right, prove this part. So the whole test is not used a lot, because this next one is much closer to our heart, right? We just take the limit, and if the limit is finite, then both series do the same thing, right? It's the same like for integral test conclusion, right? If those three conditions hold, then the integral test and the series have the same fate, right? Both converge or both diverge. Well, now for the limit test, we're going to have the same type of thinking, meaning if both are positive and the limit an over bn is finite, then they both have the same fate. And you know, because you picked something, right, for summation of bn, you know what's happening there. So you will be able to claim quickly. So limit comparison test. So we have let sequences an and bn be positive, right? That's your job. First, you make sure they're positive, and if they're positive, then we say let limit n goes to infinity of an divided by bn be L. Now I'm going to poke into it and say finite, right? So it can be 0, it could be -3, it could be 1 million, right? But it has to be some finite value. Pi, that's also good. Now, we have case number 1. If summation bn converges, then summation an converges. So this is the part where we say they share the same fate. Okay? So whatever happens with bn will happen with an. So one of the Bernoullis came up with this and was improved later. There's more to this when you take advanced calculus. But for Calc 2, this is it. Previous problems can be solved using limit comparison test. I think we had like something like 3 over n minus 4 or something, right? Summation 3 over n, but now I'm going to use plus 4 because now it doesn't matter, right? Previously, see, direct comparison is very tricky because, you might not be able to prove that sign. But for the limit, you should always be able to take the limit. This test is obviously inconclusive if the limit is, right? Well, if the limit is infinity and there is divergence, right, then it's divergence. But, yeah. All right, so my an is 3 over n plus 4. And my bn is just 3 over n. So last time I had to go and fix the problem and put the minus so that inequality works. So direct comparison works only if you have a minus. But limit works for both. It works for the minus and it works for the plus, which is why limit is used more often than direct comparison. Now we know that summation of Bn diverges by, you can say, P series or integral test. You can also just claim it's harmonic series, because by now, since we already had 2 lectures on it, by now you might memorize, right, harmonic series, 1 over n diverges. Cool. All I need to do is to run the limit and make sure the limit is finite. So I have my 3 over n plus 4 divided by 3 over n, which gives me, when 3 is cancelled, limit n over n plus 4 as n goes to infinity, and we know that is 1. So it's finite. And that's all I needed. Since limit an over bn equals 1 and summation bn diverges, the series summation of 3 over n plus 4 diverges by limit comparison test. Ta-da! So your job is to pick appropriate problem you are comparing this to and just do the limit. You will be using whatever limit works, right? So you can, whatever method. Sometimes you have to use L'Hopital rule, right? So whatever it works to solve that limit, you need the limit to be finite. It doesn't have to be 1, can be anything, right? But it has to be finite. All right, so now we're going to take a look at, let's say other 2 examples, and then this section is over. That's it. There's nothing else. So let's see. In some cases, you have to be a little bit sneaky to figure out what to compare it to. So let's see, what is this one? Summation of square root of k over k cubed plus 4 from 1 to infinity. So what do you think is your Bn, right? The one that you are comparing. Yes?
Would it be P series 1 over k squared?
There's more to it. So you did that by killing the 4, right? So what else are you missing there?
Square root, yeah.
Square root. So what is the final verdict? 1 over k. Good. So your AK is k over k cubed plus 4. Then your BK is 1 over k.
Can you go over that again? Exactly how that...
Yep. When you kill the non-essential plus 4. what happens with k and k cubed? They cancel down to 1 over k squared. Square root of 1 is 1. Square root of k squared is k, right? So we are expecting this to diverge because summation bk over here is, summation bk is divergent by p series or integral test, whatever, you care. So you have ak, then you have bk, and then divergence. So all I need to do is the limit. Limit k goes to infinity, square root of k over k cubed plus 4 divided by 1 over k. Go! How do we do this limit?
The bottom's a higher power.
Is it? We just talked about it, they're the same.
Doesn't it just diverge?
What?
The limit?
Limit doesn't diverge. Limit goes to a number for a finite value, or it does not exist.
K times the root, so it doesn't love it down. It's all going to infinity.
Yeah, you have k times the square root of that mess,
So just
and it's just that gets bigger, it gets bigger.
Start writing something. Try to do. I'm gonna read it.
I love it.
This box doesn't include. We'll put the tape over here. I'm shaking to get in the box.
It's not theirs.
Just me. Sound like some open soda. Like 2 seconds, I was like, quicker. Your answer should be 1, by the way.
Well, because there's no limit. There's no finite limit.
1.
There's not just
The
one.
answer is 1.
Oh, okay.
For the limit.
Yeah, okay. Finite limit's 1, then yeah, then it's divergent because k is infinity going to root k over k. Everything else doesn't really matter because it's all infinity over infinity and the square root of infinity times infinity.
Okay, let's take a look. So, what I'm going to do is multiply by k over k, and then go under the root and so on. So k, that cancels. Limit k goes to infinity, and now I have square root of k over k cubed plus 4 times k. Now I'm going to stuff the k under the root. So it becomes, I'm going to write out all the steps, which is square root of k over k cubed plus 4 times k squared, because when the k goes under the root, it picks up a square. So now k times k squared is k cubed, so limit k cubed over k cubed plus 4. And here we can use the property of limits, which you learn in 2.3, which was listed as one of the survival sections. In that section, you were taught that the exponents, right, if you have the whole argument of log raised to exponent, in this case 1/2, the limit can go inside. So we have a square root of the limit k goes to infinity of k cubed over k cubed plus 4, which is k cubed over k cubed is 1, right? So this becomes square root of 1, which is 1. So we have a finite limit, and the answer says, since limit an over bn is equal to 1, in this case, or finite, and goes to infinity. And, oh, the problem is in k, I'm using n's, whatever. And summation of b and diverges, because we said that was the harmonic series. The series summation of square root of k over k cubed plus 4, 1 to infinity, diverges by the limit comparison test. Ta-da! So whatever way you can take that limit, just make sure it's right, correct. Okay, one more problem, and then we're going to move on with our lives. So 36 or 37? Likes prime numbers.
29 it is.
So 37. Well, it's really cool. I mean, the prime number one is.
Let's do
Sp-
36.
Numbers. 37.
I'm just not gonna do anything until you guys agree.
Let's vote.
Yeah.
Alright.
All in favor of 36, say aye.
Bill, now you get to bring
All in
up the
favor of
donuts.
37?
Wait, hold on.
I-
Who brought the don? Oh no, both of them brought donuts.
37. Both of them.
No. I just
No?
kind of walked back in.
Oh, I thought you guys went together.
We parked around the same spot. So as I was walking up, he came in and he said, "You sure you want to leave?" And I said, "No."
So should we work in this guilt and have 36?
I'm not pulling leverage, I told you.
All I'm saying is it's prime for a reason.
We got one aye for 37. 37 it is.
No one voted for 36?
No, they did not.
I don't think
That was an
anyone
official
voted.
vote.
Official vote. Yeah, this one is
Minutes now? Yep.
run minutes. I love it. I'm going back to ends. All right, see what you can do with this. Hold on, we're not done. Lock the doors. Yeah. Save your prayers. God is not here with us now.
He hasn't been with me this entire course. Okay.
Look at this beauty over here. Come on.
I think we have different opinions of beauty.
Oh, look at this one. This is the last one. This test probably going to take about 20. 440 seconds break. We're going to do something. Cool. I don't understand the walk on these plastic walls. I'm just huff and huff and just. You don't even have to put muscle in it. Plastic. Whole thing.
Oh my god, they're not even the same root.
No, that's the beauty of it.
Can it be two of them?
What do you mean?
Can it be two different things?
No, we just do the limit real quick and be done.
Just real quick. You got it. You got it, boss.
Just do the limits real quick and that's it.
Oh. Oh, actually, yeah.
What's Bn?
The cubed root of n squared over the square root of n cubed.
Okay, so that's what's important, right? So we can work out this this Bn as
I ended up being like
n to the 2/3 divided by n to the 3/2, right? And you can even combine it into a single n as 2/3 minus 3/2. So n to the what?
5, 6.
It's 4 minus 9, negative 5 over 6. So that's going to be 1 over n to the 5 over 6. Why did I do all of this arithmetic? To get all the way down to 1 over n to the 5 over 6. Because I would be just fine working the limit with the Bn up there. Why did I go all the way down to 1 over 5 over 6?
You do that messy division, lesser chances of arithmetic error.
No, for the P series, because we need to know whether summation of Bn converge or diverge. You can't make that decision there. You have to have 1 over n to the p, right? So now that I know that Bn is 1 over n to the 5 over 6, now we know summation of Bn is summation of 1 over n to the 5 over 6, which diverge by P series. If you are still wondering, let's say you missed the last class, P series are on the list, right? So P series on the list, row 4, and it clearly says if power P is less than 1 or less, it's divergent, and if power P is bigger than 1, it's convergent. So 5 over 6 is smaller than 1, right? Therefore, it's divergent. So now, all we need to do is to run the limit, and we are done. So we have, limit needs to be finite. If that doesn't work out, then we're doomed. N goes to infinity. We have cube root of n squared plus 1 divided by square root of n cubed plus 2 divided by, and we can put n to the 2/3 no coughing divided by n to the 3/2. So it's going to be the limit n goes to infinity of, we have n to the 3/2 times the cube root of n squared plus 1 divided by n to the 2/3 times the square root of n cubed plus 2. Awesome. So this is what I have, and now I can I just need to take the limit. We have all these roots. So let's do some mathematical flexing. Ready? Would you agree that the sixth root would kill off, sixth power would kill off all of the roots? It would, right? So if I raise this to the sixth power, and then put the sixth root to counter it. I know, right? Imagine how I felt when I thought of it. So now 2 and 6 would cancel. We'll get n to the 9 times n squared plus 1 squared divided by n to the 4th, and then 6 and square will cancel. You'll get n cubed plus 2 cubed. 6th root of limit n goes to infinity. And now what you have here is n to the 9, n to the 9, and 2 squared. That means square squared is 4, and 9, so this is order n to 13, right? Divided by 3 times 3 is 9, plus 4 also n to 13, plus blah. We don't care about lower terms because they will all go to 0 when you divide by n to the 13. So what I have is the 6th root of 1, which is 1. Woohoo! Since limit an over bn equals 1 and summation bn diverge series summation of n goes to infinity for the limit. 3 cube root of n squared plus 1 divided by square root of n cubed plus 2 diverges by limit comparison test. Cool, huh? Practice taking limits. It's like 90% of your work.
We also need the homework for chapter 10.
Yes. Selena has her assignment to make sure.
Like, okay, where's the homework?
All right, good. Well, that's it, guys. That's the comparison test, also known as the last resort test. So we'll see more of this during the review. Let's take about 240-second break and then work on alternating series test. And that one is quick.